And so how, like we talked about earlier, Randall, I don't think I asked you when I saw you, but there were a lot of the same, like the people who did not reach out. There was a lot of people who did turn in this assignment, but a lot of the things that were missed were the same things. I'm not exactly sure why. So I'm just going to touch them and see if we can figure that out. And if you guys have any feedback to let me know kind of what's going on with you guys so I can correct and address everybody, that would be awesome. If not, we'll be on the right track, and that's all that we can really ask for. So this one, we have a negative, which means this is why we know this is going down, down on both sides. This is back to your quadratic. X minus 1, so these are your factors. And that's where people started getting real confused on that last assignment. Whereas your zeros are -5 and +1. And that's because back to that back quadratics where you would solve these for the for the zeros, you would solve the factors after factoring to find out what the solutions to that quadratic was. And back in the day in quadratics for Math 1 and Math 2, remember solutions is just where did it touch the x-axis. And for the most part, that's all we're doing for right now too, except in a couple of days it'll get a little more furry and fun options going on as well. But so in this case, it's saying that if I move that -1, that x equals 1, so that's a solution or a root or an x-intercept. And if I move that 5, it's x equals a -5. So that's where you see them in the graph. This is your factored form of our quadratic. And then those are the factors. So just the parentheses, what it would be that we solve to get the given zeros or where it's going to cross the x-axis. Again, since you guys and I have already been over this a lot, I'm going to go ahead and hit on in behavior statements because nobody's reached out and asked, but I know in class that's a thing that you don't even realize you don't understand it until it's too late. So we're going to go over it some more. So writing the in behavior statement. So if x approaches -infinity, x approaches +infinity, y approaches something, y approaches something. So that's the portion that we talked about last week is non-negotiable. The writing of it the order could change, but that much is going to always be said or written in quote-unquote sentence form. Your y could be that f of x again. And when x approaches +infinity, that means you're looking to the right. When x approaches -infinity, that means you're looking to the left because remember, this is +infinity, this is -infinity. So as I look to the right, my y values are going down, and that's because this arrow is pointing down. And so that's going to be as I look to the right, -infinity is down, and then as I look to the left, it is also down. Other reason you would make things that you could tell from this graph is that our leading coefficient is going to be negative because they're both down, and then our exponent, which we hopefully know this is a parabola, so you know it's a 2, but it would be even because they're both going the same direction. So same for even. Odd exponents, remember, have like an odd, like in this case where this one's down and this one's up. All right, so our next guy, so our zeros, we have 3 real zeros, and so our zeros are -2, +1, and +3. So that's your list of your appropriate zeros. They all crossed through the x-axis, so their multiplicity would be 1. And then looking at your factored form, because there's no exponent, we can assume these are 1. And that would also be another way to dictate what the multiplicity is of those solutions. And so remember, your 2s is when it bounces like this guy, and we don't have a flat line on this one, but 1s is when it runs all the way through the x-axis and back. So again, these are our factors, our solutions, our roots. X-intercepts would be -2, 1, 3. And to get from here to there, I think also showed to be a little bit of a problem. The idea is x equals 3, so working backwards from what we did over here, I need that x to come this way, or the 3 to come towards the x, because we want x to be positive, sorry. So x equals -3, and this is going to be your root here. That's what gives us that +3. In behavior statement, so if we want to look to the right first, that's fine, and this could be f of x, x to the left, is f of x, and again, so as I look to the right, in this case it's going down, so that means -infinity, which also lets us know that the leading coefficient is going to be negative. The leading coefficient controls the end of the graph, and that being like reading from left to right. And then when I look to the left, it's going positive because it's going up, and that would let us know that our exponent is going to be, or our degree is going to be odd because we have opposites. we did discuss, I don't remember if it was in our live class or with some one-offs, but you can count your directional changes. So this is decreasing, increasing, decreasing, which also lets us know that that degree and exponent is a 3. The degree and exponent is a 3 for that one, which is odd, which is why they're in opposite directions. So our next guy, we have a -1, 2, and a 4. So our solutions, roots, x-intercepts are going to be these guys. We have factors, so x plus 1, x minus 2, and x minus 4. But that x minus 2 has a multiplicity of 2. 1, either because it bounced if you were to put it in Desmos and see it, like if they didn't give you the graph, but also because of that exponent 2. So since that's to the 2, that means this 2 is multiplicity of 2. And that's usually how you're going to see it written. And so that little sentence will be right here in front of your parentheses. So -1, comma, 2, multiplicity of 2, comma, 4. Be very, very careful. This number is not your solution. In this case, it happens to be the same number. So if you mix them up, you won't see much damage on the way out. But just if it says multiplicity of 2, they will write it as a number more than they've written it as a word. But make sure you're using the number that's in the front of that sentence as your solution. So we're up, and that up lets you know that that's going to be an even exponent. So 1, 2, 3, 4. That should be a 4 exponent when we're done with this guy. Decreasing, increasing, decreasing, increasing. So that's 4 directional changes with 3 turns. And by turns, I mean this guy, and this guy. Our end behavior statement, so as x, and actually I'm going to write it the other way that I've seen it written so far. X approaches positive, x approaches negative. So even though they're saying it backwards, whoops, I'm off the screen, sorry guys. So as I look to the right, as x approaches positive infinity, which is to the right, this graph is going up. So we're just going to go back over here and put a positive with our y. And again, that y could be f of x. And then as I look to the left, our y is going to be a positive infinity again because it's going up. And we know that they're the same. So this lets us know that our degree is even, which is that 4. And our leading coefficient is positive because this one is going up. Do any of y'all have any major questions, or is this starting to make a little bit more sense now that we've worked through a couple of them?
Yes, ma'am. It's making sense.
Good, Hala. Thank you.
Oh wait, mommy, it's not. Yeah. I'm just curious. I'm slow with it.
You're good? Okay, good. Jared, how you doing, bud?
Slower.
Good, good. Do we want to do the fourth one, or do we move on to the next part? All right. So I'm going to move on to the next part because I feel like I said, it's the same group. Jared, you missed the other day, but that's okay. If you have questions, just holler. The worksheet from Friday, it looked like this, and it had a big blank over here. So our zeros, again, and I think I mentioned it as well, polynomials, the part of the reason this gets to be kind of difficult is you have a lot of new vocabulary and a lot of things to pull, and they can make it look a little slightly, just a hair different, and you guys kind of shut down on me. So don't panic. If it's polynomial, it's talking about roots, it's talking about factors, you have the information, especially when we're done with the unit, you will definitely have had exposure. It's just a matter of making sure that you're staying focused and don't freak out. So this one, our zeros, roots, x-intercepts is going to be -1, 0, and 2. We wrote them in the other worksheet. We had them kind of separated so you didn't get it mixed up. So then the factor to -1, since that is x equals -1, we're going to move that -1 over here with x. And so the factor would be x plus 1. In this case, x equals 0. Move the 0 over. We're still just going to have x. X equals 2. Move our 2 over here with x. X minus 2. And that's your factor. Your multiplicity, it crossed through in all 3 places. So multiplicity of all of these are 1. And unless they're giving you a list, they're really not going to discuss multiplicity of 1. Like, more times than not, you're not going to see multiplicity of 1. Some of the worksheets I have made for you guys or things I have typed up, I put it there just to make sure you're paying attention to the number 1 when it's multiplicity of 1. Is not important, and it's sort of helped me identify when you guys are running down that rabbit hole. So that if you see it, it's not commonly written out. It's assumed that it happened one time. And the reason, just some foreshadowing to where we're going tomorrow, the reason you want to be able to get from here to here is we can write this polynomial. Now, it's not 100% accurate. There's some gray areas to this. But if you remember how to multiply, if we multiply these three together, we have a really good starting point at what we think this polynomial should be when we write it out. Some things you want to pay attention to is this is a down on the right side. So the end. So that means we know our a value in the front has to be negative. So we know that it's going to end negative. We know these are opposite. So that means this definitely has to be an odd exponent. And that's going to matter when we start getting into our imaginaries to help a little bit. But we know this one's real, real, and real because it actually touched the x-axis. And that's going to be x, 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 which is going to give us that x cubed since there are those three directional changes. And you can multiply. This is another one of those situations where your work is not going to necessarily look like mine or your neighbor's. But at the end of the day, the answer just has to be the same. So as a quick review, if you don't remember, and if you use FOIL, FOIL's great. I'm a big fan of box when they start getting bigger than binomials. And after, this one's not going to get much bigger than a binomial. But after you start doing like a quartic function or a function to the 6th power and you have 6 of them or 4 of them or more than just 2, they get a little bit bigger. And organization for distributive property for a lot of students is not super consistent. And the box method just helps you to keep things a little more like in their seat and in their place. So you would work in, so x times x is going to give me x squared, negative 2 times x times 1, negative 2 times positive 1 is a negative 2. And I did have a tutor session with one student. This, if you remember this is actually long division backwards relative to the way we did the box method for long division. It's the same idea. And that's why when we did it, we started here, I said, what did you multiply this by to get this? And that's where the top for long division came from. But the same idea. But we're going back to our math 1 version of this. So that means we have x squared, negative 2x, and positive 1 is going to be a negative x minus 2. I check off my list of factors. Please believe me, because if not, you will all of a sudden just run off because you're super excited you did math really well and it wasn't that hard and you're pumped and it's a multiple choice question and that answer is there. That's not it, because we know this is a cubic function. So we need to make sure we catch our last guy. And you can either do box again, or in this case, since it's just a term, like a single term, a monomial, we're just going to distribute it through. So x squared becomes x to the 3rd power. Negative x becomes negative x squared, because again, that's 2 x's. And that x times a negative 2 equals a negative 2x. But we know it has to be negative in the front, so we're going to put a negative in the front. For now, that is a possible, without getting into our stretches and the depths and all the big bumps. This is a good idea starting point of where this polynomials equation could be. And there is an EOC release question that gives you a list of roots, and you have to be able to multiply. And again, you're going to do this big time tomorrow, that's what tomorrow's lesson's on, but just since you're here, we can already discuss it. So looking at number 1 here, another one of those graphs, back to our multiplicity conversation, this bounced. So that means negative 3 with a multiplicity of 2. Remember, bounce is 2. We have a negative 1. It only happened once. So multiplicity of 1. Coming back up, we have a positive 1. Multiplicity of 1, because it went straight through that line. And that means we have 1, 2, 3, 4. Multiplicity of 4. So down, up, looks good. Both of our arrows are pointing up, so they're the same. So we know the exponent needs to be even, and 4 is even. And then we know this is positive. So at the end of the day, when we multiply this all the way together, that polynomial function should be positive when we're done doing our work as well. And so negative 3 multiplicity of 2, to write your factors of that would be x minus 3. And you could write it twice. Or x minus 3 squared. The negative 1 multiplicity, plus 3, because the negative 3. So it's the opposite, because we're going to set it equal to 0, then solve. So then your negative 1 is x plus 1. Positive 1 is x minus 1. So 1, 2, 3, 4. Or you could use this guy this way. As far as multiplying it times each other to get the final answer. So like tomorrow's work. Excuse me, I'm about to sneeze. Oh, all right. This x plus 3 squared is not going to be super helpful because you will accidentally mess up. Because that really does mean write the whole thing twice. And you'll get creative and start to distribute the 2. And that's not exactly, that doesn't work this way because it's attached by addition. So it may be better, in my humble opinion, for you guys to write them all the way out. Because when we start multiplying them together, that means we're going to do it 4 times. So we have negative 2 with a multiplicity of, can anybody tell me? So multiplicity of, that negative 2 is an answer. It crossed through, so it's a multiplicity of how many times?
3.
3 is another solution, but just looking at that 2, negative 2, it crossed straight through the line. So is it multiplicity of 1, 2, or 3?
1.
Yes. Whew, good job. Cross through. So a terrible made-up story that's probably not very mathy and may not work for you, but arguably, if you're running a race and you run straight through the finish line in first place. If you bounce off of it, you're not finishing first place. At best, you're turning back around and can maybe hit it second place. And then if you flatline and just run right or left away from the finish line, maybe that'll help you remember third place. So if it runs straight through the x-axis, you're in first place. So multiplicity of 1. And then we cross the x-axis at 0. Multiplicity of how many at 0?
1.
Yes.
Oh, it is 1?
It is 1. Because it crossed straight through the x-axis. This one just looks more like a diagonal line. Not quite as steep as the other one. If you like disregard everything else. And then 3. Multiplicity of...
I mean, I want to say 1, but it looks like it's curving.
Don't worry about the curve part. So, let's see if I can say it a different way. It is 1. As far as its intersection with the x-axis is the only part you have to worry about. Like, right there at when y is 0, for that 1 split second, does it bounce off of that place? Does it kind of flatline at that place and kind of hang out there for a minute and then move? Or does it just run straight through? And that being, trying to find a different color, sorry. This intersection right there, that intersection, and that intersection. So if I was to zoom in to, like there's a lot going on, so I can see where we're, so let's.
It's like, so on the problem to our right, the positive 1, that would be a multiplicity of 2, right? Since it's like not on there at all, just bounces off.
Yes, yes. So like you're only really actually looking at, as far to the discussion of multiplicity, we're looking at like that much of the graph.
Okay.
And so maybe when I closed it in, now do you see how it's just like a perfect X?
Right, yeah.
That means multiplicity of 1.
Okay.
And then, so like you just said, remember moving on to the next one, and we'll just jump over to this one guy. Whoops. There's a whole lot going on there more than just crossing through the finish line and winning the race. You like completely change directions. And that's when you start looking to see what kind of multiplicity is. Most of the ones I've seen, especially that you've had to see from a graph as far as like test style questions, it's 1 or 2. At most 3, because those 3 functions, they assume you've had enough exposure to between Math 1 and Math 2, a cubic function, quadratic function, like those kind of things, that you would probably identify those. I have not seen a 4 where you would have to choose it graphically because it does a little, like it sort of flatlines and bumps all at the same time. It's like a long bump. So,
can you show us an example of a flatline for like multiplicity?
Yeah. Hold on. Maybe not right here. Nope, sure didn't. I don't think I printed. Yes, I did. Hold on, I just gotta figure out where I put it. Because that's gonna be some of your work for tomorrow.
Miss Sigmund.
Yes, ma'am.
So like one with 3, it would show like a line like dragging across the x-axis and then slowly like.
And then it kind of drops off. Yep. So there it is. This one from our worksheet together, that yesterday or last week's worksheet. Yeah, it's all relative to its relationship to the x-axis. So when it just sort of like, ooh, stalls out, and then it's like, okay, just kidding, I'm gonna keep going. That's 3. All evens cross through. Odds, no wait, that's backwards. Odds cross through. It's just how fast does it cross through? Like 1 goes directly through. 3 is still going through. It just sort of like detours to get through the x-axis. And your evens are going to be your bounces. So like we know that's going to be a 2 because it bounced directly off. Your 4 would be a multiplicity of 2 because it bounced off straight back. And then the multiplicity of 4, like I said, it's pretty hard to like really differentiate from a graph, which is why I didn't do that to you. Algebraically though, like if you're looking at your factored form, that means it's raised to the 4th power. And that means it has a multiplicity of 4. Whatever the power or degree of that factor is also your multiplicity. So I'm feeling really confident about asking this question. So -1, multiplicity of what? Yes. And then we come over here, we got +1, multiplicity of yes. And 2, multiplicity of yes, because it just boogies straight on through. So then when the reason, again, this is important is when they ask you, one, they just ask you these style questions as well, but it really gets to the EOC release questions. Write this equation. So if I know my root is -1, that means my factor is x plus 1, because if I set it equal to 0, that's how I get x equals -1. With a +1 multiplicity or of 2, +1 root means x minus 1. Multiplicity of 2 means it literally happens twice. And then 2 multiplicity of 1, that's a +2. So the factor is going to be -2. And so I would multiply these 4 binomials, and you just have to sort of start knocking them off. Like take 2, multiply them together. Then you'll get a trinomial usually. And then take 1 and multiply it by the trinomial. Then it gets a little bit longer. And then you're going to take that and multiply it by the next. I don't want to spend a lot of time doing that right now because the multiplication part is part of tomorrow's lesson. And I think you should be okay as far as the multiplication part, as long as you understand root to factor, and multiplicity of 2 just means that it happens twice. All right. So this, it was briefly covered, but not. And this is another one of the EOC release questions. And because I love you guys for consistently always showing up, I feel like if I discuss it with you right now, it's going to be a breeze. Versus on a video, it may not be. So this is to the 4th power, right? Or degree of 4, leading coefficient of a +2. So as far as your end behavior statement, we know the leading coefficient is +2, so it's going to end going up. 4 power is even, so that means it's going to be up, up with some wiggles in the middle. The other thing they can ask you when given these are, what are your combinations for real and imaginary roots? And I think we did discuss it briefly on Friday. Imaginary has to be in pairs. So you can only have even number imaginary solutions because you're going to have a positive and a negative of that imaginary. So real. So our options for combinations for 4th power. So I can have 4 real solutions, and that just means that this crosses the x-axis 4 times. Then I could have 2 real solutions and 2 imaginary, because that still gives me 4 when I'm done. And then I can have 4 imaginary. I can't have 3 of either because then I don't have an even leftover number to call imaginary. So if I said 3 real, the problem is you can't have 1 leftover imaginary. Whatever number I choose has to leave me 2 left over to be able to call it imaginary.
So it's an even number?
Always even. Imaginary is always even. You either have 2, 4, 6, 8, and so on. It can never be 1, 3, 5, 7, anything like that. Now, reals can be odd numbers. They just wouldn't be attached necessarily to a This next one's 5, so you'll see it here. So you have a degree of 5. So that means I could have 5 real. And then from there, the combinations, I could have 4. Can I have 4 real? Actually.
No.
No, because it only leaves one more hanging, right?
Yeah.
And imaginaries can't go in pairs of 1. So if I go down and I say, okay, so I'm at 5, and then I'm at 4. 4 is no good. If I do 3 real, how many does that leave me left over? 2, right? So 2 imaginary. So 2 imaginary, and that gives me that 5 total because it's the 5th degree. And then if I went down to real, that would give me 2 real. If I said 2 real, will that work?
I would disagree. You got me lost right here.
Okay, hold on.
Yes.
Okay, I'm going to write it out and then we're going to cross it off as wrong. So if I say 2 real, how many is that left? How many left over out of the 5 do I have?
3.
So that means you would have to write imaginary 3. But ding, 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 big alarm should be going off. Is that an even number? No. So then this one is a no-go. This is not an option. So if I go down to 1 real, because that's the next number, right? How many does that leave left over? 4. Is that an even number?
Yes.
Then you're good there. So I can have 4 imaginary. And then I think there was one more I was thinking about it.
Real can be odd.
Real can be odd. They travel by themselves. Imaginary always travels with a partner. Yep, real can be odd. Odd and even. Imaginary has to be even.
Wait, how could a real number be even if we have no real numbers that are even right now?
The problem is because our output is odd. So if I said 4 real, that leaves me 1 imaginary, which is not a thing. Like, he's not a loner kid. He has to have a friend. He won't go anywhere without somebody. And then if I said 2 real, which would be your even, the problem is that I have 3 left over. So I can't leave 3 to be imaginary.
I screenshotted this. This will help.
Okay, and again, this is more, like I said, I keep telling you, some of this stuff is just painfully, you just have to do it, and then you're like, oh, and it clicks. So with the power of 3, so I'm looking at 3, I can have 3 real, because remember now, when I say real, don't disconnect. Real means that this graph is crossing the x-axis in three places. So as I mentioned before, kind of like in Math 1 and Math 2, when you had a quadratic, how many times did it cross the x-axis? It could bounce off what you would say was one solution, right? And that solution would be multiplicity of 2. They don't talk about that in Math 1 and Math 2. But it just bounced. Like the parabola hit it and kept going. So that one solution actually happens twice. And then it had it cross in 2 places. So you had 2 solutions. But when your parabola was hanging out in one of the other quadrants and not touching the x-axis at all, we said no solutions. But now, because we're older, smarter, and better, we know that there's actually 2 imaginary, because you have to be able to make the function. So there are something we can multiply together. You just didn't have the imaginary, complex, and all those kind of fun skills that you're going to have before we're done here. So they've always existed. You just never really discussed it from that purpose. So real is when it touches the x-axis. So this function could touch 3 times. And this is a cubic function. So remember, it looks kind of like this if it's real basic. And then it can get real squirrely as well. So for 3 real just means that it went 1, 2, 3 through the x-axis. And the number below.
This is due to me not paying attention, but how do you know it crosses the x-axis 3 times?
So right now, you don't. We could graph this. This is just potential solution combinations. So assuming you have no calculator, you have no graph paper, just what are the options that are even on the table to potentially happen to this graph?
Desmos.
Well, yeah, yes. EOC says, though, do you understand that imaginaries come in pairs of 2? Do you understand reals can come in all the solution sets, like all of them? This is just a conversational. Like, so, like if you take a multiple choice test and you have nothing, someone just hands it to you. Like the ACT, Robert. And then you look at it and you're like, okay, well, I mean, A kind of could be right. B could be right. C is definitely not it. So you're just making your list of potential choices.
Okay.
Yeah. So you're good question, because at this point you don't know. I only sketched that to the side so you knew the x to the third power, kind of what we're talking about when we say real versus imaginary. So I'm going to do this again. Can I have 2 real for this guy? Because if I have 2 real, how many do I have left over?
1 imaginary.
And is that allowed?
No.
No, because imaginary is not a loner. He can't go out. He's a scaredy cat. He only goes with friends everywhere. So that one's not 1. And then next would be 1 real, 2 imaginary, which is great because he has his buddy to hold his hand, and 1's hanging, and we're still 3. And then I have 2 more that are 3s. We'll go back to the 4s just to remember. So we have 4 again. So that means 4 real. Can I have 3 real?
Nope.
You can't have 3 real because my total's 4, right? So that means it leaves me with 1. And you can't have. He's gonna have a panic attack. Can't be that way. You got to keep him happy.
Is this one where like the even 2 and 2 imaginary would work? Like 2 real and 2 imaginary?
Yep.
Okay.
And that's why when I was first trying to like figure out, and sometimes if I'm having one of those days where I have a lot on my mind, or like there's a lot going on in the room, literally make a list and cross off the ones that you realize don't work. I mean, it doesn't hurt. Versus leaving one out, because it's not super difficult. It's just remembering which ones you can and can't write. So if you write them all down, then you go, that's not allowed. Not allowed. So 2, my leftovers are imaginary. 2 because it's a 4. Then if I do real 1, that's imaginary how many?
3.
And is that allowed? No, because there's 1 guy left off, like I said, having a panic attack. Imaginary has to have somebody hold their hands. But don't forget, 4 total. So I guess theoretically it'd be real 0 if we're making our list down, which leaves me imaginary how many? Yep. And that's even, so that works. Yes, ma'am.
I'm not sure if this has to relate to these types of questions that I've seen before, but I've seen these questions where it was like it had like a bunch of numbers, and most of them had like the letter I in front of them.
Yep, we're gonna get there.
It's like mostly on the SAT and the ACT.
Yes.
Is it I imaginary?
Yep. Exactly.
Oh, for real? That's what it is?
Yep. That is all it is. It just means that it's an imaginary number, and that just means there was at some point in the computations, I is the square root of -1. So if you ever remember, like I said, I just remember in math 1, and kids would be like, just grinding, doing quadratic formula like a boss, getting after it, and all of a sudden they end up with like a square root of -16, and they plug it in their calculator thinking they're doing all this hard work, and all of a sudden your calculator says error. Because you can't take the square root of a negative number. And the solution to that is you pull out that I, which just makes note that that negative did exist, and then you can take the square root of a lot more numbers that way. Yeah. And we are going to get into that in 2 days more.
That's great, because that's going to be on the SAT, and I'm taking it next Saturday.
Oh, cool. Then you at least won't be blindsided. Awesome. And then from there, I had some more in behavior practice, and then I pulled some synthetic division practice. We are hitting right at overtime. So it's up to you guys. What do you need? How do you feel about in behavior?
Wait, is in behavior everything we just did?
Nope. Everything we just did was polynomials as a whole, Robert.
Okay.
In behavior would be as x approaches positive infinity. So that stuff, or you saw it as f of x approaches and x approaches. Try to think of all the ways you've seen them so far. And then where you have to fill in beside your y or beside your f of x. Because remember, f of x and y are the same thing. It's just a different notation. Oh, heck, you're here. Let's do it. So number 1, your leading coefficient is at +5. So that means we know to the right it's going to go up. And then our degree is 2, which is even, which means they have to be the same. So it's going to go up. So up, up. And relative to your y-axis, going up is positive infinity. Ta-da, you just wrote an in-behavior statement. Look at number 2, our leading coefficient. Now, I will say, there are people on the Ed puzzle. It has to be in standard form. And by standard form, I mean descending order for exponents. The highest exponent has to be in the front. And sometimes you'll have to reorder it because they just want to make sure you know all the things. So you have to make sure these are kind. They put the highest exponent in the front for all of them. They're already in standard form. But make sure they're in order, because if they're having like an x to the 4th in the back, that's actually the tallest person in line. And again, going back to picture day, you know how they lined you up from either shortest to tallest or tallest to shortest? Same kind of idea. Everybody needs to be in order. There needs to be a space holder if there's somebody absent. So you put in that 0, which you talked about in synthetic and long division. But making sure everybody's lined up correctly and we're accounting for all of those that should be there. So though this is written backwards with the y in the front and the x in the back, this is still as x looks to the right, which is positive infinity, and as x looks to the left. The right is your end behavior as it finishes, which is what your leading coefficient tells you. So in this case, it's a -2. So when I look to the right, I know it's going to go down. So look to the right, negative infinity. Your degree is 2, which is even, again, which means it's going to be the same. So that means to the left, it's going to look down. We outlasted the principal. That's awesome. I wondered when he was going to be like, oh my God, are you done yet? Yeah. Oh, so leading coefficient for this one's +1. Degree is 3. Your in behavior statement, again, you can write it in any of the orders. So x approaches, y is going to approach, y is going to approach. Remember, positive infinity is right. God, that makes me laugh. Negative infinity equals is left. As I look to the right, because it's a positive, that means I know I'm going to go up. And because the degree is odd, that means the left is going to go opposite. So as I go to the right, definitely positive. As I go to the left, definitely negative. Oh man, I'm on record still too. That sucks. Definitely going to lose that portion of the video. That is literally my life.